Good evening. My name is Nikitha, Dharanipragada, and I'm a senior neuroscience major, and my PI is Dr. Helsley, and I'm in the Department of Internal Medicine. So obesity affects over 40% of adults throughout the United States, and it's clinically defined as having a body mass index of 30 or above. Obesity is important because it can affect other health issues like diabetes, hypertension, and cardiovascular disease. Our lab studies carnitine palmitoyltransferase 1A, or CPT1A, and this is an enzyme that is highly linked to all these different diseases, but we aren't really sure of its functionality across different cell types. So now the question is, what is CPT1A? Well, CPT1A is a rate-limiting enzyme in fatty acid oxidation. Essentially what it's doing is that it's taking in fatty acids and it's converting them into acylcarnitines. These acylcarnitines drive beta oxidation in the mitochondria. But essentially what you need to know is that it's just taking fatty acids in and it's converting them into usable energy for the cell. So CPT1A is historically shown to be highly expressed in the liver, but I've included the gene expression data of different human tissues to show that it's also highly expressed in adipose tissue or fat tissue. And so our lab was interested in understanding how CPT1A functions in fat tissue. So we used two different models. We used a cell culture model and we also used a mouse model. For my cell culture model, I used 3T3L1 fibroblast cells, and I transformed them into fat cells using a special media. At day 0, we expect no fat within our cells, but by day 4, we see an abundance of fat droplets within these cells. Following this, we deleted CPT1A in our cells using CRISPR-Cas9, which is a gene editing tool. So such studies have shown that CPT1A has some linkage to insulin sensitivity. And insulin is a hormone that's responsible for glucose uptake in fat cells. So we wanted to understand the sensitivity between our control and knockout cells. And so to do this, we looked at our control and knockout cells and we treated them with either saline or insulin. And we looked at different proteins in the insulin signaling pathway. And we saw that when we treat our cells with insulin, our protein phospho-IR beta, which is the starting protein in our insulin signaling pathway, is actually similarly stimulated in both our control and our knockout cells. When we go further down this pathway, though, we see that proteins like phospho-AKT and phospho-ERK actually show less expression in our CPT1A knockout cells compared to our controls. So this impairment in expression shows that there's some insulin resistance happening within our knockout cells. We wanted to see how this would translate into a mouse model. So to do this, we used an adipose CPT1A knockout line, and we fed these mice on 16 weeks of a high-fat diet. A high-fat diet is a diet that's commonly used to induce obesity in mice. So following this, we had also measured body weights throughout this entire process. And we saw that our female knockout mice had a greater percentage body weight increase compared to our controls. We also saw that when we inject our mice with either glucose or insulin, our female knockout mice show more glucose intolerance and insulin resistance compared to our controls. So my future directions are to look at different mechanisms that are linking insulin sensitivity to CPT1A. Thank you. I will take any questions that you guys have.
What are GTT and ITT?
So GTT stands for glucose tolerance test, and ITT stands for insulin tolerance test. So essentially, we're just injecting glucose or insulin into these mice.
Yeah, so on the chart on the bottom with the female GTT, so the lines, you have the knockout,
Yes.
which is higher, but then they cross at the end. Is there any, what do you attribute that to or think that may be caused by?
Well, essentially what's happening is that these female knockout mice are taking in glucose, but then they're also faster to clear it out compared to our controls. And at the end, it's just showing that that's just the end of the experiment. I don't really know as to why they do so, but this is in a mouse model, so there are always variations.